While the solubility of most solids dissolved in water will increase as the temperature of the water increases, the opposite is true of gases. As the temperature of the water increases, solubility of gases decrease. And this graphic here shows gas particles as these red spheres, and when water has a lower temperature, more gas molecules are dissolved, and when the temperature of water is higher, fewer gas molecules are dissolved. The solubility of gases also depends on pressure. And Henry's law states that the solubility of a gas in a liquid is directly related to the pressure of that gas over the liquid. So if we want to increase the solubility of a gas in a liquid, such as carbon dioxide in pop, we can increase the pressure of carbon dioxide above that liquid. And we can increase pressure by increasing the number of molecules. So when you open a can or a bottle of pop, that fizzing sound that you hear is the pressure, the higher pressure of the carbon dioxide in that container equalizing itself with atmospheric pressure. So as soon as you open a can of a carbonated beverage, then those carbon dioxide molecules leave, they exit the container, and with fewer gas molecules above the liquid, there is lower pressure and less carbonation. So as a carbonated beverage sits, it will become uncarbonated as the carbon dioxide is not as soluble because the gas pressure above it will be lower. Henry's law can explain the gas exchange that occurs in the lung. So we'll look at oxygen going into the bloodstream and carbon dioxide leaving the bloodstream. So when we inhale air from the atmosphere, the pressure of carbon dioxide is 0.3 millimeters of mercury, whereas the pressure of oxygen is 160 millimeters of mercury. When we inhale oxygen into our lungs, oxygen becomes dissolved into our bloodstream, and that's because our bloodstream has a pressure of oxygen of 100 millimeters of mercury. Since atmospheric pressure of oxygen is higher than that, the higher vapor pressure of the oxygen causes more oxygen to dissolve in the bloodstream. Let's look at carbon dioxide. Carbon dioxide has an atmospheric pressure of 0.3 millimeters of mercury, which is much less than the pressure of carbon dioxide in the bloodstream at 40 millimeters of mercury. Because of the lower pressure of atmospheric carbon dioxide compared to bloodstream carbon dioxide, the carbon dioxide in the blood will dissolve out into the lungs. So if the pressure is higher, solubility will increase, and if the pressure above the liquid is lower, then solubility will decrease.